Dear children, let's study about the gaseous state. The general characteristics of gases. How the particles are arranged in gases we know. In gases, particles are loosely packed with a large distance between the particle. Because of large distance, the intermolecular interactions are very weak. Intermolecular attraction and intermolecular repulsion between the gaseous molecule very weak. So gas molecules are free to move all the space available to them, and hence gases have no fixed volume, no fixed shape. They take the shape and volume of the container. Because of weak attraction between the molecule, gases are highly compressible. They can be compressed easily. Density of the gases very low. Gases are lighter. Moreover, gases can exert pressure. Means gas molecules are always in motion. They have maximum kinetic energy. They move in zigzag manner without any proper direction. During their movement, these gaseous molecules will collide with each other, and also they collide with the walls of the container. The force applied per unit area on the walls of the container by the gaseous molecule is called pressure of the gas. Gases can exert pressure, means when they collide with the walls of the container, they exert a force on the wall. That force acting on unit area is called pressure of the gas. Gases can exert pressure. So these are the general characteristic properties of gases. In this session, we are going to study about the gas laws. Behavior of gases can be explained on the basis of the measurable properties of the gases. Measurable properties means pressure, volume, the space occupied by the gaseous molecule, temperature, then amount of the gas. Amount of the gas we express in terms of number of moles of the gas. So these are some of the measurable properties of gases. Density, another example. The behavior of gases can be explained on the basis of these properties. How these properties are related to one another, that is given by gas laws. The first gas law was given by Robert Boyle, which is known as Boyle's law. Boyle's law gives pressure-volume relationship. How pressure and volume of gases are related. The law states at constant temperature, for a fixed amount of gas, fixed amount of gas means fixed number of mole, pressure of the gas vary inversely with the volume. This is called Boyle's law. At constant temperature and constant amount of gas, pressure vary inversely with the volume. When pressure increases, volume of the gas decreases. When pressure decreases, volume of the gas increases. Means when pressure decreases, gases expand and occupy more volume. What is the condition? And this happens at constant temperature and constant number of moles, fixed amount of gas. If you replace this proportionality sign by equality, there comes a constant K1 by V, where K1 is the proportionality constant. If you rearrange this equation, V is taken to the left side, pressure in the volume is equal to K1. That is, pressure in the volume is a constant. If you take a gas at constant temperature, if you take a gas with the pressure P1, volume V1, the gas undergo expansion. On expansion, what happens? Pressure will be reduced. Pressure will be reduced to P2, volume will be increased to V2. This is the new pressure, new volume, final pressure and volume. These are the initial pressure and volume. According to Boyle's law, PV is a constant. So we can write P1 V1 equal to P2 V2 equal to a constant. On rearranging this equation, we can write P1 by P2 is equal to V2 by V1. In this equation, if out of 4 parameters, if any 3 are given, the fourth one can be calculated. You can use this equation for solving problem-based questions. Boyle's law can be shown graphically, explained graphically also. When we plot, if you plot pressure against volume, pressure is plotted against volume, we get a curved graph. The graph is plotted at constant temperature. The constant temperature plots are known as isotherm. So this is an isotherm. What are isotherms? Isotherms are pressure volume graph, pressure plotted against volume graph at constant temperature. Constant temperature plots are known as isotherm. So if this is the plot at a constant temperature of 200 Kelvin, similarly another isotherm can be drawn at a different temperature. For example, at 400 Kelvin we get another isotherm. So isotherms are constant temperature graph. Pressure versus volume graph plotted at constant temperatures are known as isotherms. We can also express Boyle's law graphically by plotting pressure along the y-axis and 1 by V along the x-axis. That is this equation. P is equal to K1 by V. This is an equation for straight line. We get a straight line graph with the intercept 0. And the slope will be equal to K1. Slope of this graph will be equal to K1. So this is another graphical representation of Boyle's law. We can show Boyle's law graphically with another curve. If you plot pressure into volume, the product of pressure and volume against pressure. According to Boyle's law, pressure into volume is a constant. It is independent of pressure. So whatever be the pressure of the gas, the product of pressure and volume will be constant. We get a straight line graph parallel to the pressure axis. That means this value is a constant at constant temperature. This again represents Boyle's law. So the Boyle's law, the mathematical expression and the graphical representations. And from Boyle's law, we can also find a relationship between pressure and density of the gas. According to Boyle's law, pressure and volume are inversely proportional. Pressure is equal to the constant K1 by V, volume. We know that density is equal to mass divided by volume. Volume will be equal to mass divided by density. Substitute volume, this equation here in Boyle's law. We get P is equal to K1 divided by mass by density. Rearranging, we get K1 into density divided by mass. See, this K1 by mass is a constant because K1 is the proportionality constant. Mass of a substance is also constant. So K1, a constant divided by another constant, we get another constant, right? That is, let it be K dash. Let the new constant be K dash. K dash into density. That means pressure is equal to K dash into density. So how pressure and density related? Pressure vary directly with the density of the gas. That means when pressure increases, gases become more denser. Density of the gas increases. When pressure decreases, density of the gases decreases. Means at high pressure, gases become more denser. Particles of the gas come closer and their density increases with the pressure. So this is the relationship between pressure and density that can be proved on the basis of Boyle's law. Thank you.